Let's continue with part B of this question, where our u of t is sine of t, and earlier on we have already do a Laplace transform for sine of t, and we get our u of s equals to 1 over s squared. Okay, so basically now our y of s becomes the transfer function multiplied by u of s, and remember the transfer function is 10 over 5s plus 1 multiplied by 3s plus 1, and we need to multiply this with our input, which is s squared plus 1. Okay, so now again, for us to be able to get to y of t, because remember our objective is to get y of t, we need to do a partial fraction. Okay, so by partial fraction, we are going to separate that equation into numerator for each roots. Okay, I hope you notice that s squared plus 1 will give you a complex conjugate roots. So we need to also include that component in our partial fraction. The first part is the same as before. We just put a over 5s plus 1. But the value will be different, yeah, because our roots are different. 3s plus 1. Okay, I don't need to have that. Okay, now since we have quadratic function, or basically s squared plus 1, the roots, when you do, the numerator, when we do a partial fraction, we should write it like this: cs plus, you can put d, but I don't want to put d because most of the time d represents denominator or differentiation, and e most of the time refers to error, so I'm going to put f. Yeah, it's really up to you as long as you're comfortable. And this is s squared plus 1. Okay, all right. So for a and b, since it is a real and distinct root, we can solve it the way that we did it in part A. Okay, so let's do a first. So a is basically 5s plus 1 multiply with our y of s, which is 10 over 5s plus 1 multiply with 3s plus 1 multiply with s squared plus 1. And remember, we are going to evaluate this at the roots, and the roots for this is s equals to minus 1 over 5. Okay, so you evaluate that, you would get, let's cancel first what we can cancel, and then we will have 10 over 3 multiplied by minus 1 over 5 plus 1 multiply with minus 1 over 5 squared. That will be, that will give us 1 over 25 plus 1. Okay, so you solve that, and eventually your a is equals to 625 over 26. Okay, all right. Now let's do b, same method. My b is equals to the roots of that, which is 3s plus 1 multiply with overall y of s, 5s plus 1 multiply 3s plus 1 s squared plus 1, and then I will evaluate that at s equals to minus 1 over 3. Yeah, so you cancel first the roots with that and then you evaluate. So 10 over 5 multiplied with minus 1 over 3 plus 1 multiply with minus 1 over 3 squared. That will give you, subhanallah, so s squared plus 1 is minus 1 over 3 squared. That would give you 1 over 9 plus 1. Okay, and you solve this. This would give you b equals to minus 27 over 2. Okay, so for a and b, due to they are having real and distinct root, so you can solve it this way. But for cs plus f, we cannot solve it like that. Okay, what we need to do is we are going to do a cross multiplication. Okay, so we are going to cross multiply this equation here. Yeah, okay, so basically when I cross multiply that, I would get 10 equals to 5s plus 1 multiply with 3s plus 1 multiply with s squared plus 1. Okay, all the denominator, and then it will multiply with a over 5s plus 1 plus b over 3s plus 1 plus cs plus f over s squared plus 1. Okay, so when we cross multiply this, I would get this one. Sorry. S squared plus 1, okay, plus b, this is 5s plus 1 multiply with s squared plus 1 plus cs plus f multiply with 5s plus 1 multiply with 3s plus 1. Okay, so you solve that. Yeah, first I need to expand that, expand that and expand this before I can properly multiply. Alright, so here I have already expand the equation. First I expand this part and this part and this part, and then I multiply with the a, b, c and cs plus f. Okay, so when I expand, I put all the a's together, the b together, and this is from the cs plus f. Yeah, okay, then I rearrange the terms according to the power of s that they have. So the first one is s cubed, and then s squared, and then s, and here s to the power of 0. Okay, just like the normal way, the usual way that you use your cross multiplication. So here, remember, what we need to determine is the value of c and the value of f. So when I look at this equation, I am going to use this part and this part only. The other two part, meaning for s squared and for s, I don't actually need to complicate my life, yeah, because I already have the value for a and b early on. So for s cube or s to the power of 0, let's do that. So let's say I want to start with that. So we know that on the other side of the equation, remember this part here, we have 10. Yeah, so this is 10, this is 10, this is 10. So definitely I'm going to use this first to determine my f. So I have 10 equals to a plus b plus f. So basically my f is actually 10 minus a minus b, and you can just proceed as usual. This is minus a just now is 625 over 26 minus with minus 27 over 2. Okay, you solve that, and you will get f equals to, this is basically, let me see, let's quickly do this. 260 minus 625, 27 minus, sorry, 27 multiplied by 13 will give you 351, and everything over 26. This would give me minus 14 over 26. Yeah, you can actually simplify this, so it becomes minus 7 over 13, or you can just maintain. Okay, let's try to simplify. Divide by 2, divide by 2. So basically I have my f is, sorry, my f is minus 7 over 13. Yeah, okay, so let's continue with s cubed. S cubed on the left hand side of the equation is 0. Yeah, when we look at this equation, this is s0, s to the power of 0, but for s squared and s cubed we don't have any value, so it is 0. So 0 is equals to, let me put it in blue, s cubed is 0 equals to, just now we have 3a, yeah, from here, 3a plus 5b plus 15c. Okay, so let's bring that down. 3a plus 5b plus 15c. So what I want is my c, so basically c is equals to 3a plus 5b divided by, sorry, it should be a minus, yeah, minus 15. So let's do this. I have minus 3 multiplied by 625 over 26 minus 5 multiplied by minus 27 over 2, divide everything over 15. To solve that, you would get minus 4 over 13. So this is my c. Now you have everything. You need to put it into your y of s equation again. Alright, so my y of s is a over 5s plus 1, so my a is 625 over 26 divided by my denominator plus my b is a minus just now, so I have 27 over 2 over 3s plus 1, and then I will plus with my cs plus f, and my c here is a minus, so again I have a minus 4 over 13s plus with my f, and my f is also a minus, so this is basically, let me make it easier, it should be 4 over 13s minus 7 over 13. Okay, and this is s squared plus 1. Okay, so again we need to transform this, we need to do an inverse Laplace transform so that we can get our y of t. So let's do an inverse Laplace transform for that. So now you can see that we have 4 terms that we need to do a Laplace transform for. The first 2 terms, this one and this one, you have actually done it before in part A. Yeah, so what we can do, we can simply actually rearrange this. So we have 625 over 26, and we need to divide that by 5, because the denominator you need to divide by 5. 5s plus 5s divided by 5 become s, 1 divided by 5 becomes 1 over 5. Why? I hope you still remember in part 1 just now when we refer to the Laplace transform table, it is equal to this one. Yeah, so it should be that. Okay, so this one, when you Laplace that, okay, minus, you inverse Laplace, same thing for the second one. 27 over 2, we need to divide that by 3 over s plus 1 over 3. Yeah, okay, now for the third term, it is minus, okay, you can see what we have is s squared, s over s squared plus 1. Okay, when we refer to the Laplace transform table, okay, I hope you can see what we have is actually, we have this s over s squared plus omega 1. Sorry, omega squared. Sorry. So basically, our omega is 1. And the Laplace transform, the inverse Laplace transform should give us cosine omega t. Okay, so for that part, we will bring 4 over 13 out, and we can inverse Laplace our s over s squared plus 1. Yeah? Okay. And for the fourth term, okay, when you look at the partner, you can see you have omega over s squared plus omega squared, and that would give you sine omega squared. So you have to adjust your equation so it matches with the Laplace transform component. So here what I have is minus, okay, you have minus 7 over 13, but remember you need to have your omega. In this case you are lucky because your omega is 1, so basically what you have is over 7 over 13, and you inverse Laplace 1 over s squared plus 1. Okay, so you put all the terms and you simplify all the terms. You will have the first one, 125 over 26 e to the power of minus t over 5 minus 9 over 2 e to the power of minus t over 3, and then minus 4 over 13 cosine t minus 7 over 13 sine t. Okay, so this is our y of t. Okay, next we need to find what is y of t as t goes to infinity. But you can see here what you have is alright, next what we need to do is we need to determine what happens to y of t as t approaching infinity. Okay, I hope you notice that you have a cosine and sine term in your y of t, so this give an indication that you have an oscillation, and this oscillation basically does not converge. Yeah, so what we are saying is that limit as y of t goes to infinity, yeah, basically our function does not converge due to the cosine and sine term. Okay, all right, that's it.